Welcome everybody to the seminar about QUAREP-LiMi, the initiative for quality assessment and reproducibility for instruments and images in light microscopy. So what was the motivation for the establishment of QUAREP-LiMi? Why standard metadata reporting, common protocols and tools? When experimental results cannot be reproduced or show a large variability, then for a microscope user it's sometimes quite difficult or impossible to judge if the metadata reported are insufficient, the instrument has a problem, or its sample preparation or biological variability, or even altogether. Metadata have to be collected and stored properly and reported and published using a common framework to allow reproducibility. The specs and the performance of an instrument when it's bought and set up at the user side is sometimes not transparently and clearly defined, nor is it easy to follow over time. There should be a clear description in the user manuals accepted and worked out together with the companies about the use of measurement and quantification tools, and possibly tools coming with a new instrument. Tools should allow in an automated manner to check some of the important performance parameters of an instrument, as well as follow and store their values over time. Major sources for problems and disagreements in experimental results, measurements, classify status, performance or testing, instrument specifications are the measurement protocols and conditions not available or improper use of tools and influences like temperature, dirt, and other things. So what is QUAREP-LiMi and how is it developed? Quality assessment, quality control, reproducibility, and metadata in light microscopy is a topic the community discussed over more than 20 years at FOM and ELMI meetings and other similar occasions, many times. Still, progress seemed very difficult, and only relatively slow improvements were achieved. The reasons? Complicated topics involved, still some or maybe too many needs to be identified, many and diverse groups of stakeholders are involved, researchers using light microscopy, light microscopists, image analysts, companies and suppliers of light microscopy, equipment and software, software developers, scientific publishers, funders, standard organizations. QA and QC might or will, for all stakeholders, first induce more workload. A positive outcome or benefit of QA and QC is not clear, and results could cause trouble or headache for some or possibly even all of the stakeholders. But maybe now we have reached a point of no return, and all will have advantages. So finally it should or has to be a win-win situation for everybody involved. This is the growth of the international QUAREP-LiMi initiative. So you see from 107 members in 2020, we are now near to 500 members worldwide. The member count has increased by 500% in 3 years, and about 30% of the members are female, and we have members now from 36 countries. What is very important for QUAREP-LiMi, we have a very large number of companies. Only the logos of some of them are shown here. And this counts to about a quarter of the members coming from manufacturers. We have, in addition, members from standard organizations, and the large extent is members from academia. QUAREP-LiMi is organized in working groups. Currently, we have 13 working groups. The working groups 1 to 6 are tightly connected to the topics of the confocal ISO norm 21073. So they try to measure the topics covered by this ISO norm. Workgroup 7 connects workgroup 1 to 6 tightly because it's about metadata, so it's about all what has to be measured and stored within the working groups 1 to 6. We have a coordination working group, which is work group 9 for planning and funding, and we are in the process of exchanging or transforming this into a steering board. We have the working groups 11 and 12, which are mostly about integrating what is published and shown about the light microscopy experiments in publications. Work group 13 is about phototoxicity, and then we have the work group 10, which is all about the overall image quality. I think this is the most difficult working group within QUAREP-LiMi, and Thomas is part of this as a co-chair, and I think he can nicely explain to you in detail why it's so difficult. We have the working group 8, which is currently named white paper, and this will be the new working group training and education, because it's clear the success of QUAREP-LiMi is very much depending on how we can transfer what we are doing to the whole light microscopy community. And this new diagram, which is shown here in blue and green, these are the QUAREP-LiMi colors, tries also to summarize how central work group 9 is and how the working groups 7 to 12 are more or less combining or bringing together all the other working groups, and it's more integrating what is worked out. Work group 14 and 15, we hope that we will have these working groups as new working groups in the near future, covering film and environment, which is very, very important for many of the measurements which are performed within QUAREP-LiMi. To allow an efficient communication between the 500 members of QUAREP-LiMi, we have a Nextcloud server where it holds currently 560 gigabyte of data. What do we store there? So we have the member and working group lists. Databases with measurement tools are actually saved on Airtable. All the workgroup meetings are recorded, and the agenda and minutes can be downloaded from the file server. We keep our protocols or develop our working group protocols on protocols.io, and an Umero server is ready to store the measurement data, which are currently held on the Nextcloud. And we have published a bunch of papers, which I will tell you later on. The output and presentation to the outside is very important for QUAREP-LiMi. So important is our website, which currently holds approximately 120 pages. We have a YouTube channel where we upload movies for training and education. I mentioned already protocols.io. We have a GitHub organization repository where programs and tools are saved, developed by QUAREP-LiMi, and we use Airtable for data collection. We also are a member of ImageSC. For the social media, we have a LinkedIn account, a Slack account, and a Twitter account. And this is, depending on the work groups, used more or less for communication. The presentation to the outside is very important for QUAREP-LiMi. We were lucky to have a special issue in December 2021 with 6 publications from members of QUAREP-LiMi in Nature Methods. Very important, I would also have to mention here clearly the RTMFM paper from Faglaris et al., which came out in Journal of Cell Biology in 2022. So even if this was started long time before QUAREP-LiMi. I think it's a community effort, not only from the French community, but it is adapted by many QUAREP-LiMi labs and members. We are working tightly together with standardization organizations like DIN and ISO. So 2 German QUAREP-LiMi members were already part of DIN when we started QUAREP-LiMi, and I'm very happy that we managed that more people joined, like Laurent Gehlmann, Orestes Faklaris, and Judith Lacoste from Canada. So this helps that what we are working out in QUAREP-LiMi also reaches the standardization organizations, and they are happy about that. I want again point out that important is that we have so many QUAREP-LiMi members coming from the industry. So currently we have 62 member companies with 128 members. And this list is much too long that I can go into the detail, but you can watch the webinar and see what is going on. Working together with the companies helps also to quickly set up macros for recording QUAREP-LiMi protocols. And a good example is here Nikon and Tor Labs. So a nice element macro for recording power measurements with the Tor Labs power meter. More or less the same macro is now ready also for Zeiss Zen Black and Zen Blue. We also have a collaboration with API and the BAM in Berlin about a calibration system for intensity, which is named QuantiFlash. 3 of these instruments are currently tested as prototypes in different labs of QUAREP-LiMi. Another example of joining forces with company members in QUAREP-LiMi is shown here. So the workgroup 6 concentrates on XY tables and the Z focus. We designed a prototype for measuring the precision and performance of XY tables, and hopefully we can extend this also to the Z focus measurements. So prototypes will be made and then tested within the working groups. And here we aim for a very simple and cheap solution so that it can be used with automatic measurement protocols. Currently, QUAREP-LiMi has no funding for a direct research project. Recently, we were lucky in getting funding together with BAM and EBD and GatterQuant for developing calibration tools for easy automatic measurements of resolution, spectral calibration, and sensitivity. These tools will be distributed and tested within the QUAREP-LiMi consortium to further improve them. QUAREP-LiMi and the industry. What is my vision? So the major topics are talking, finding, and agreeing on a common language, definition of terms describing microscopes and add-on equipment, defining and agreeing on common measurement protocols and tools for companies and users, and defining and agreeing on a common file format containing the information and properties about the equipment when it's delivered and produced, and allowing as well to save additional information about its performance and condition over time. This is clearly a lot of work in the beginning for all stakeholders, but it can and will be quite valuable for both sides. Talking with and learning from and understanding each other. Learn and experience and document how the equipment is behaving over time. Finally, it will be a win-win situation for everybody involved. That this vision can become reality shows the metadata camera model partnership between industry, Workgroup 7 and Workgroup 2. This is for developing consensus between users, custodians, experts, and manufacturers to revise the the 4D and BINA OME metadata model for cameras. The big four major camera producers worked in this together with microscope companies and the QUAREP-LiMi community to develop or renew the metadata model. So it's an exchange of information with manufacturers to streamline the documentation of image acquisition. A glossary is now put together by a subgroup of experts explaining all used metadata fields in detail. And we hope to finish this project with a new revised camera metadata model in autumn 2023. How successful we are can be seen that there was an editorials or even two editorials in Nature Methods in July 2022 describing in detail what QUAREP-LiMi is doing there together with the industry. So from this camera example, it's clear we have to extend this joint task with the industry in many other working groups. So we have to finish now the area detectors, and then we will proceed with light sources, point detectors, filters, filter changers, XY tables, focus devices, objectives, heating devices, incubators, and then the big microscope main bodies. As well, we can continue in including sample holders or certain devices like dishes, chambers, or multi-well plates. This is a huge effort, and it's clear that it can be only done if many people work together, and the timeline we have to expect for this approach is approximately 2 to 3 years at least. If you want to know much more about QUAREP-LiMi, there is the perfect chance to do tomorrow. So we will have there the 6th biannual meeting of QUAREP. We will present what QUAREP-LiMi is working on, what our working groups have achieved over the last 2 years, and what we hope to achieve in the future. It will be the perfect event to inform yourself about our work and how academia and industry work together on a common aim. Find the agenda here with this QR code, and you have to register for this event with the QR code shown below. Up to now, already 250 people have assigned to this meeting, and I hope it will be a great success. Looking forward to seeing some of you there. So this is the end of my webinar. Thanks a lot to all QUAREP-LiMi members for making this possible. And thank you very much for your attention.